using what we've learned about Booleans and comparisons, we're going to extend the challenge from last time a little bit. And so here you'll notice I'm actually in the variables project because I've added on to that. So if you'll remember before, we were working with an application that would work with the quadratic formula. And so before, we would enter in values for A, B, and C, and we would be given the discriminant. Now that we've seen an introduction to comparisons, what we can do is make some claims about the results. Now, the discriminant is an important number in the quadratic formula because it tells you whether your equation will have 0, 1, or 2 real solutions. And these are just your real, non-imaginary, non-complex numbers. If your discriminant is exactly 0, there will be 1 real solution. If the discriminant is greater than 0, there will be 2 real solutions. And if the discriminant is negative, there will be no real solutions. So a good example, just to test this out, is 1, 2, 1. The discriminant for 1, 2, 1 is 0. So we see here, does the equation have exactly 1 real solution? True. Does it have exactly 2 real solutions? Is false. And does it have exactly no real solutions? Is also false. So if you do this correctly, you should see that one of these should be true and the other 2 should be false. So let's run it again. Okay, and there we go. And let's see. So another one we could try is 1, negative 1, 1. Okay, and that gives me a negative number, which corresponds to no real solutions. And that's what we see here. This, by the way, is an easy one to come up with because when you do factor a sum of 2 cubes, this is the other factor. So if you're familiar with cube factoring, you've seen this polynomial before. Okay, so we'll just do one more. And this time we'll go with 1. Then we'll say 5 and 6. And we get 1. 1 is a positive number. And so we get 2 real solutions. So if you're building on from what you saw before, all of this code is the same as what we saw before. So you shouldn't have to change anything to this section. All this does is we're adding 3 lines for each of the 3. So remember, it has exactly 1 real solution if the discriminant is 0. It has exactly 2 real solutions when the discriminant is a positive number, and it has exactly no real solutions when the discriminant is a negative number. So see if you can get this behavior on your machine, and then the next video we'll go over one possible solution using what we've seen.